You know that decimal number on the periodic table that we've been ignoring? For example, boron 10.81, carbon 12.01. Well, it's time that we talked about it. This number is known as the atomic mass, or the average atomic mass. And it is a weighted average of the masses of the isotope of an element. Great, clear as mud. What in the world does that mean? Well, a weighted average is when one number counts for more than another. For example, your grades are a weighted average. Your tests are weighted to count 60%, and your classwork is weighted to count 40%. So the tests count more than the classwork. Well, when you have different isotopes of an element, you usually have more of one isotope and less of another. Therefore, the one with more counts for more. Let's talk about how we're going to keep these straightened out. There are three words with very similar names that are really easy to get mixed up. Let's look at those three. You've already learned about the atomic number. That is the whole number on the periodic table, and it is the number of protons. It's the number at the top of each box. So, for example, boron is 5, carbon is 6. That is the number of protons, which is the atomic number. And then the mass number is not on the periodic table. This is the number that is given to you in the name. For example, carbon 12 or carbon 13. That has to be given to you because that number is not on the periodic table. It's the mass of a single isotope. If you have one isotope, you add your protons and your neutrons, and that gives you your mass number. Then, finally, this decimal number. This decimal number is made of all the different mass numbers of the isotope averaged together but weighted so that the one you have the most of counts the most. And that gives you your atomic mass. Now you see how easy these are going to be to confuse. Atomic number, and then atomic mass. Great. So the atomic number and the mass number are whole numbers. If it has the word number, it's a whole number. Then, if it does not have the word number, then it's a decimal number. Hopefully that will help you remember. Now let's take a look at what in the world this average atomic mass means. There are three major isotopes of hydrogen: hydrogen 1, hydrogen 2, and hydrogen 3. 99.9% of the hydrogen in the world is hydrogen 1. It weighs 1 atomic mass unit. 0.1%, 1/10 of 1% of the hydrogen in the world is hydrogen 2. It weighs 2 atomic mass units. And there's a teeny amount of hydrogen 3, and it weighs 3, but there's so little you can neglect it. There is a negligible amount. So they went to average the mass of these three isotopes. Now if you average 1, 2, and 3, you add them together, 1 plus 2 plus 3 is 6, and you divide it by the fact that you have three numbers. 6 divided by 3 gives you 2. That's an average of 2. But look, on the periodic table, the average atomic mass is 1.008. Wait, when you average those numbers, you get 2, not 1.008. And even if you just average 1 and 2, you get 1.5. What's the deal? Well, 99.9% of the hydrogen weighs 1. So the average is going to be much closer to 1 than it is to anything else. Now, you're in luck. You do not have to do the math to figure out the exact average atomic mass or anything. You just have to be able to do it in your head like that. Oh, we have the most of this one, so it's going to weigh about this much. So let's take a look at another. Let's say we have two isotopes of chlorine, chlorine 35 and chlorine 37. Chlorine 35, of course, has a mass of 35. That is the mass number, the whole number that is not on the periodic table. It's the mass of that isotope. And the mass of this isotope, of course, is 37. So which one do we have more of? Well, first, we need to look at the average atomic mass of chlorine. Find chlorine, and the decimal number, 35.45, is the average atomic mass. Now, do we have more chlorine 35 or more chlorine 37? Well, is this average closer to 35 or closer to 37? Oh, it's closer to 35, so we have more chlorine 35. All right, what about a backwards question? We have oxygen 16, it has a mass of 16, and 99.8% of the oxygen out there is this isotope. Then 0.2% of the oxygen weighs 18. What is the approximate atomic mass of oxygen in whole numbers? So, is your mass going to be closer to 16 or closer to 18? Well, you have more of this, so it's going to be closer to 16. In fact, when you look at the decimal number here on the periodic table, whoa, 16.00. Now, I'm sure if you went far enough on the decimal places here, you would have a few numbers coming after the decimal. But, wow, it rounds to almost exactly 16. So you try the next 3 problems and see if you can get the answers to this.